refer back to it if you get stuck.
Okay.
So, is it going to work now? It looks like it's going to work. So here's the 4 elements. Unlike the previous ones you've done, there's also fluorine in here. But notice that we also have information about how much fluorine there is. Okay? So what's the first thing we need to do in a problem like this? Yeah, Hannah, yours.
You could find the amount of grams included in the C of C and O and
Right.
H and O in
Right.
their respective.
Right. So remember 7.7 grams of CO2. We're going to turn this into moles of CO2. And then we're going to turn this, I just know all these molar masses. And then we're going to turn this into moles of C, like so. So I need someone to give us the answer for this. And we can do the same thing for the H2O, right? 2.52 grams H2O over 1 times 1 mole H2O over 18.02 times, what goes here?
You have
2
moles
of H over 1 mole of H2O.
Right.
And that's because it's H2O.
Exactly.
And it's okay.
Yeah,
It's okay to like, okay, yeah.
Sorry, I should say 1 mole of water. All right. Who got the number for the red problem? Yeah, you.
Oh, no, I got it for the second one.
Okay, you.
0.17496.
17496 moles of carbon. And you?
Me, I don't.
No, you. What did you get?
0.263. Oh.
263, whatever, moles of hydrogen. Okay. Whoops. Oh, I see. Go away. So, what do we do now? Where it gets trickier. Yeah, you, Jenny.
I think it's the grams of fluorine into moles of fluorine. And
True.
subtract them from the grams of
Pause. This is trickier than you think. We can't directly use this information because this is based on a different sample. Ellie?
I was just going to say convert the carbon and hydrogen.
Okay, later we can convert carbon and hydrogen into grams. We have to do something else first. Mercury?
Should we find the amount of O so that we can find the amount of O?
But we can't do that yet. You'll see why in a second. Sakinson?
Okay.
Loud voice.
And maybe set up like a proportion, so 3.63 grams over like 0.58 grams equals 4.16 grams over X.
Excellent. So this is the total of that new sample over 0.58, thank you. And what, that equals what?
4.16
Over X.
Right.
Or
let's call it F to make it more obvious. And do you all see why Sarah suggested doing that? Because that will give us the mass of fluorine in that original sample. So what does this variable actually equal?
Mass of fluorine.
Yeah, and as a number?
Oh, wait.
0.66.
Kyle, go.
No. I'm wrong.
Go.
I did in my head.
Oh, I could be wrong too.
Wait, hold
Okay. 0.664868.
Yeah, that's what I got there.
Okay, great, that's good enough. So, and this is grams of,
46, whatever.
whatever, so grams of fluorine. So then, what we need to do is turn this into moles of fluorine. And now we can do what someone, I forget who suggested, add up, turn the fluorine, the carbon, and the hydrogen into grams, and then add them all up and subtract that from that original mass to find the mass of the oxygen that's left over.
And why wouldn't you just like do what you did for the C and H and combine the oxygen totals? Can you not do that? That does not exist.
You can't find this.
Hey, oxygen is excess.
No.
That's why. Okay.
Jenny, come right here. Right here, talking to the computer. Run, 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 run.
Okay. Well, oxygen is excess, so you can't find the exact amount of it because there's excess O's in CO2 and H2O.
Okay.
Oh my God.
Good. So I don't want to do all the math crap from here because it's boring and stupid. But did people see how to solve it from this point? Or let me
Can we just say it out loud or something?
yeah.
It's that last part where you have to divide by like the little amount of moles. It's the smallest amount of moles, right?
So let me say the whole thing.
Yeah.
Okay. So here, and I'll even write it up here to make it more clear. So what we do is we turn moles of carbon, hydrogen, and fluorine into grams. Add them. Subtract the total mass from that.
Wouldn't we subtract that from the total?
Hers, yeah.
Subtract the total mass.
Yeah. However you say that. Then that gives you, oops, that's going to, so that should give you, awesome. All right, you know what? We're going to try it. Green gives the, so that gives the mass of oxygen turned into moles. And then this is the part you were talking about, Sabrina. Divide all the moles by the smallest number of moles. All the mole numbers by the smallest. And then we do that multiplied to the whole thing that Kyle came up with in his little poem. Okay, cool. You good?